Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Murakim Al-Azhari, numerator AA19136, and for our experimental theory. And the component in lab first is we use the component resistor. Resistor resists or limit electric current in a circuit, and the unit for resistor is ohm. Second is capacitor. Capacitor store electrical charge and are found in a variety of application. They used to be called as condenser, and the unit for capacitor is farad. And the third one is inductor. Inductor, also known as coil, are used to store energy in electromagnetic field, and they serve many useful functions in electric circuit. And the unit for inductor is Henry.
Okay, for the voltage across an element is the work energy required to move a unit positive charge from the negative terminal to the positive terminal. The unit of voltage is the volt, V. Voltage is expressed as energy W divided by charge. V equal to W over Q, where V equal to voltage, W equal to work or energy, and Q is charge. Next, current. Current is the time, rate of flow of electric charge past a given point. The unit of current is the ampere. An ampere is 1 coulomb per second. And next, power and energy. Power is the rate of expending or observing energy. V equal to IV. Energy is the fundamental ability to do work. Here we can see power absorbed by an element and power supplied by an element.
Okay, for the pre-lab section, for the first question, according to figure 1.1 below, write down the total resistance in mathematical formula and calculate the RT. According to the mathematical formula provided, we can calculate the result of the resistor by using the given information. Okay. For the figure 1.2, same as figure 1.1, we can use the mathematical formula to calculate the resistance from the further circuit. Okay, lastly, equation 2 refer to the theory. Calculate power from figure 1.3 below. Next, determine the number of kilowatt hours of energy when you use the equivalent of 1000 of hour for 1 hour. Okay, formula for power is V times with I, which means we can change it into V times V per R. Then insert the information given, which is 10 to the power of 2 divided by 100, which will produce 1 kilowatt. 1 watt. 1 watt for 1 hour. For the 1 hour is 1 kilowatt. 1 kilowatt times 1 hour is equal to 1 kilowatt hour. Thank you.
Assalamualaikum. For the result and equation, I, Ahmad Uzaifah, and Ahmad Zakir will present about it. Okay, for the first one is resistor. We will need to calculate the resistor value by its strip color. And for the first resistor, it consists orange, brown, and gold color, and its value is 330 ohm plus minus 5%. For the second one is red, and gold, and its value is 2200 ohm plus minus 5%. For the third one is green, blue, orange, and silver, and its value is 5600 plus minus 10% ohm. Okay, for the last and fourth one is brown, black, yellow, and silver, and its value is 100,000 ohm plus minus 10%. Okay, the next one is we need to calculate the series and parallel resistance. Okay, for the series circuit, the resistance is 1.15 thousand ohm, and for the parallel circuit is 12.876 ohm. Okay, I will pass it to Ahmad Zakir.
For capacitors, the total capacitance in series circuit is much more lower than the total capacitance in parallel circuit. This can be shown in figure 4, in which the measurement it get is 22 pictofarad, while in figure 5 you get 12.2 microfarad. For inductors, we can see that the total inductance in parallel series is lower than the lowest inductor, in which in figure 1.9 you can see it got 11.5 Henry, while in figure 1.10 we got the measurement of 1 microhenry.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ifa Shahira binti Abdul Jalil. Today I will tell about you the basic electrical components, quantities and units laboratory. So I will tell about you the question and discussion. The first question is, what is the purpose of specifying the tolerance of the resistor? The answer is, the tolerance of a resistor is the maximum difference between its actual value and the required value, and is generally expressed as a plus or minus percentage value. So the purpose of specifying the tolerance of the resistor is, the tolerance is the percentage of error in the resistor's resistance, or how much more or less you can expect a resistor's actual measured resistance to be from its stated resistance. So tolerance band is useful in identifying which resistor will give you a more accurate resistance reading. So the smaller the tolerance percentage is, the higher the precision in your measurements. The next question is, determine whether the resistor in each circuit or figure below has possibly been damaged by overheating. This question can be done by calculating power for compare it with the power rated on each resistor respectively. Okay, so the formula of this question is power equal to V squared divided by R. We need to find the power for each circuit, such as circuit 1, circuit 2 and circuit 3. So for circuit 1, when we use this formula, we will get the power is 0.81 watts. Circuit 2 is 2.5 watts and circuit 3 is 0.384 watts. So the power rated for circuit 1 is 1/4 watts, which means the circuit already exceeds the power rated on resistor by 0.56 watts according to the calculation of the power. Next, the power rated for circuit 2 is 1 watt, shows that the circuit also already exceeds the power rated by 1.5 watts according to the calculation of the power. This means that the circuit 1 and circuit 2 has been damaged by overheating. Lastly, circuit 3 has not been damaged by overheating because the power does not exceed the power rated on the resistor. Thank you, that's all from me. Assalamualaikum warahmatullahi wabarakatuh.
Lastly, for our conclusion, in this experiment, we are able to identify the basic of electrical component such as capacitor, resistor and inductor, and we were also able to understand how to use RC meter and calculate the resistor value, and we're also capable to calculate the capacitance, inductance and power based on the formula given, whether in series or parallel components. And from this experiment, we also discover some errors during the measurement of the total resistance caused by the overheated resistor, and this problem is solved by changing the resistor with a new one. We also repeat the measurement at least 2 times in order to get accurate value that are close with the result of the calculation. That's all from us. Thank you.